Okay, so next up we're going to take a look at scientific notation. This is probably something that you've done quite a bit with in the past, but we're going to do a little bit of a refresher with it to make sure that you're up to speed on it. So remember that when we're using scientific notation, what we want to do is we want to take really, really big numbers that are kind of awkward, or really, really, really small numbers that are kind of awkward to work with, and we want to make them a little bit easier to work with. So the way that we do this is we're going to take our decimal point, and we're going to move our decimal point. When it's a big number, we're going to move it to the left. And what we're going to do is we're going to count the number of spaces that we move our decimal point. So this is going to be 1, 2, 3, 4, 5, and 6, 7, 8, and 9. So we've moved our decimal spot over 9 times to the left. What we want to do is we want to put our decimal point behind one number. So basically what we're doing is we are having a 1 spot. So if you go back to placement, the 1 spot is the first spot to the left of the decimal point. The 10 spot 2 places, the 100 spot 3 places. So what this will give us is the number 7.5. Now to finish off the scientific notation, we have to multiply it by 10 to the something. So we're going to use our old x. So whenever we're doing scientific notation, always use the old x to signify multiplication. So 7.5 times, and then our base is going to be 10, and then however many times we move that spot to the left, that's going to be the number that we're going to use. So this is going to be 10 to the 9th. So 7.5 times 10 to the 9th is the same thing as 7.5 billion, which just so happens to be around about the number of people on Earth. Then if we look at this number, 0.0000256. So this one has no special meaning, it's just a number that I put up there. But what we want to do is we want to take a very, very small number and put it into scientific notation so that it's easier to work with. So we're going to take this decimal spot, but instead of moving it left, this time we're going to move it right. So we go 1, 2, 3, 4, 5. And again, we're trying to get to the point where we're going to have one integer to the left of that decimal spot. And so this time we went 5 units to the right, or 5 spots to the right. And what we end up with is 2.56. Now we need to finish off the scientific notation just like we did here. And we're going to go times the base of 10. But this time, since we moved 5 units to the right, instead of it being 5, we're going to say to the -5th. This indicates to us that this is a very small number as opposed to this one, which is a very large number. So let's say that we have a situation where we need to multiply scientific notation. What we're going to do is we're going to, again, multiply anything that is alike. So we've got our numbers 1.2 and 1.2, which are alike, not because they're the same number, but because they're both going to be the decimals that are out in front. Then we've got 10 to the 8th and 10 to the 7th, which are alike because they are our base of 10s. So anything that's alike, we're going to multiply together. So when we see 1.2 times 1.2, we know that we're going to get 144 because 12 times 12 is 144. Then we've got to figure out where are we going to place our decimal point. So our decimal point tells us here, since we've got 2 of them, 2 spots, 1 spot there and 1 spot there, that we're going to go 1, 2 there. So our decimal point is going to make it 1.44. Then we're going to go times 10 to the 8th and to the 7th. Remember that whenever you're multiplying the same bases, you're going to add the exponents. So since we got 10 to the 8th times 10 to the 7th, the solution is going to be 10 to the 15th. So the solution to this is going to be 1.44 times 10 to the 15th. Our next problem is going to be a sample of division. So we've got 2.4 times 10 to the 5th divided by 1.2 times 10 to the 8th. So again, anything that's alike, we're going to divide that. 2.4 divided by 1.2 is going to be 2. Then we bring down our times. 10 to the 5th divided by 10 to the 8th. Remember that what we're looking at is, you can look at it one of 2 ways. We can go 10 to the 5th minus 8, or we can say we've got 5 tens in the numerator and 8 tens in the denominator, so we're going to be left with 3 tens in the denominator after we cancel. So that's going to be over 1 over 10 to the 3rd. The easier way of looking at this one, because we don't want anything in the denominator, is going to be 10 to the 5th minus 8. So if we do 10 to the 5th minus 8, we're going to get 10 to the negative third. And that's going to be your solution. So you got 2.0, or just 2, times 10 to the negative third. So in this problem, we're going to be looking at how many molecules of water are there in a cubic meter of water. We're not going to be concerned with setting up the word problem. We're just going to look at the math on this. So what we've got is 3 separate bits of scientific notation that we've got to combine together. 9.98 times 10 to the 5th, 3.34 times 10 to the 22nd, and 1.13 times 10 to the negative 7th. Now, you're going to need a calculator for doing things like this. The 9.98, the 3.34, and the 1.13. Just not going to be able to do that on your own, or it's going to take you a very, very long time to do that on your own. So you would use a calculator for something this complicated. When we multiply these together, we get approximately 37.7. So I'm going to go ahead and write that in. Really what I'm looking at here is the 10 to the 5th, the 10 to the 22nd, and the 10 to the negative 7th. We're concerned about those because we need to multiply those together. So remember the rule that anytime that we multiply like bases, we're going to add the exponents. So we have 10 to the 5th, and then a positive 22, so we're going to put plus 22, and then a negative 7th, so we'll put minus 7 there. So that's going to give us 37.7 times 10 to the 27th to the 20th. But we're not done yet, because this isn't in scientific notation. Remember that in order for it to be in scientific notation, the decimal point has to be after the 1 spot. Right now we have the decimal point, the decimal point is after the 1 spot, but there's a 10 spot in front of it. So what we need to do is we need to move this to the left. Remember that anytime that you move your decimal point to the left, you're going to be adding to your exponent. So since we're going to move it 1 spot to the left, we're going to add 1 to our exponent. And so that's going to make this 3.77 times 10 to the 21st, and that's going to be our solution for problem number 3. So in problem number 4, we're looking for the kinetic energy of an object with a specific mass that is moving at a specific velocity. So we're given the formula 1/2 mv squared, and then we're told that m is equal to 1.3 times 10 to the third, and v is equal to 3.1 times 10 to the third. So what we're going to do is just go ahead and substitute our known values into this equation, or into this expression. So we got 1/2 times 1.3 times 10 to the third, times 3.1 times 10 to the third, but this one is going to be squared because we've got the square on the velocity. So we're going to have to make sure that we take this 2 and we distribute it through to both that 1 and to that 3 as well. So let's go ahead and knock that out first. We've got 1/2 times 1.3 times 10 to the third, and then 3.1 squared times 10 to the 6th, because remember, we're raising an exponent by an exponent, so that means we're going to multiply them together. Now what I would suggest to you is anything that looks alike, go ahead and get it together. So this 1/2 is the same thing as saying 0.5, so we can go 0.5 times 1.3 times 3.1 squared times 10 to the third times 10 to the 6th. Okay? And what we can do now is just go ahead and run this through a calculator, and we are going to get, for this part right here, we're going to get 6.2465. And then for the next part, we're going to get 10 to the third times 10 to the 9th, or 10 to the third times 10 to the 6th, gives us 10 to the 9th. So our solution to this problem is going to be 6.2465 times 10 to the 9th. For problem number 5, we're going to do a word problem that has to do with population density. Now, population density is arrived at by taking the total number of people in a country, or total number of people in a region, and then dividing it by the area of that region. So what we can see here is that in the country of Angola, in a specific year, you had 1.21 times 10 to the 7th people over 4.81 times 10 to the 5th area of land, whether they're using miles or kilometers. So All we're going to do with this is, again, divide anything that looks alike. And again, you're going to need a calculator on this. 1.21 divided by 0.48 by 4.81 is going to give you approximately 0.252. Well, we're going to do a 2 there instead of an x, because we're going to do the x next. So the x is going to go there. 10 to the 7th divided by 10 to the 5th is the same thing as saying 10 to the 7th minus 5. So we've got 0.252 times 10 to the 2nd. Now what we want to do with this is remember that anytime that we're doing scientific notation, we need that decimal point to be after the first number. So we're going to take that and move it one spot to the right. If we move it one spot to the right, that means we're going to subtract 1 from the exponent. And so now we're going to have 2.52 times 10 to the 1st. And that'll be your solution for this problem.